This camera is actually really cool because it's like extremely easy to load it into video editing software. It's in a format that works really well for that, even though like it's kind of weird and old and ghetto and all that. Yeah, absolutely. You can buy these cameras for like $5 on eBay nowadays, but they're cool. I have a drawer of them.
A drawer?
Well, they fail. This connect, you can see this one's about to fall apart. The connector right here is not very well built. And so then when you, hey, at $5, you buy them by the drawer. You know what I'm saying? They're easy to work with. Okay, so this was which one, 29?
Yes.
All right, so 29 was saying solve this system of equations. 4x plus 4y. By the way, Sierra, if you're watching on the video here, it's 8 o'clock already. We've been talking to students about different things. We're finally getting started here. So we're talking about number 29 on page 65. And Lisa came up here and has been working on showing us how to do this problem. And so she took the problem that was 4x plus 4y minus 4z equals 24, and 2x minus y plus z equals negative 9, and x minus 2y plus 3z equals 1. This matrix right here is a representation of that same system of equations. It is just a neater little way to solve the same system of equations. Now, we are on the Gauss-Jordan method of solving equations, which is not my favorite, to be honest, but it is one of the ones we have to do for certain kinds of problems. So, we have to do row operations on this matrix until we get where it's ones along the diagonal and zeros everywhere else to the left of that bar. Okay? Hey, does anybody happen to remember from pre-calculus what we call that, where we have a matrix that is all zeros except for ones along the diagonal?
Row echelon form.
That is, well, okay, when we're solving a Gauss-Jordan problem, when we get it, it's in row echelon form. That's exactly right. But what was the, it's actually reduced row echelon or some such damn thing, but it's a variation on that.
Ones and zeros.
With the ones and zeros, what is that called?
Oh,
That was an identity matrix.
0, 1, 4.
Do you remember that word, identity matrix?
The one
An
along
identity
that.
matrix is a matrix with all zeros except for ones along the diagonal. That's going to be an important word later in this chapter, but we aren't there yet. But it's a way of saying the number 1 in a matrix. Okay. Anyway, so we're just trying to get that. Because when she did loop-de-loop-de-loop-de-loop, look at all these row operations she did. Let's just look at where she was headed. She eventually got herself into this form where she had ones along the diagonal and zeros everywhere else. And when you've done that, you can just pick these 3 values off that are to the right of that augmented thing. Yeah.
Okay, so I have a huge question.
Okay.
So I did this, my brother actually did this for me and then he walked me through it. Okay, so.
It's a safe place, you can admit that.
Yes, but, so do you see the part, it's like in the top row at the very, it's kind of at the end, R1, switch R3?
Yep.
He said that's okay
Yep.
to do.
Switching rows is okay too.
Okay, I didn't know.
I don't know,
you
does
could
the
do
book give that on that table? There's a table there of what operations you can do.
I didn't
It's
know
in a
that
green
was
box. It's in a box someplace. What can you do? What can you do? Row operations. You can, number 1, interchange any 2 rows. This is on page 55. On page 55, you can interchange any 2 rows. Number 2, you can multiply the elements of any row by a non-zero number.
I did not know that until.
Yep. Or 3, you can add a non-zero multiple of one row to a non-zero multiple of the other row. That's well, the main one you do is that third one, right? We're adding one row to another, or subtracting it, or we multiply it by 3 and take away. And so you were going all kinds of happy here. So, for example, row 1 minus 4 times row 3 becomes the new row 1. And since it didn't hurt anything, she did this one at the same time. Row 2 minus 2 times the row 3 is row 2. And say she got these to go away. And apparently her brother, older or younger?
Older.
Okay. I had this picture of like this savant child
No, he's like 20.
He's actually 80.
playing with blocks and also doing Gauss-Jordan matrices. Anyway, her brother went this way and then went this way. And well, okay, as long as you're just getting to, let's say, something 0, 0, 1, then it was just an ordering the things around this way to make it better. So with a whole bunch of steps and a whole bunch of neatly documented what she was doing, she eventually got to here, which is another way of saying 1 times x plus 0 times y plus 0 times z equals negative 1, which means x is equal to negative 1. Or 0 times x plus 1 times y plus 0 times z is 23, or z is 20. y is 23, and so on. If she didn't do anything wrong along the whole way, you're just watching me spin on there, right? Or
No,
you would-
actually, every time I go to install something, it says an error occurred.
show me. Uninstall.
Like, it'll do that, and the message will pop up.
Error. An unexpected error has occurred. The server is unable to process this request, right? And it didn't actually get rid of it? Or is it actually gone?
I think it's actually gone.
Okay, what's probably happening is as you're removing those C++ libraries, we're helping Natalie over here if you're wondering, she's got a computer problem. As you're removing those C++ libraries of code, things that are running in the background on Autodesk are failing. You know what I'm saying? Like, it needed that, and all of a sudden something that was running in the background, monitoring your cloud account or some such damn thing, is failing.
And all of those, like, failed
It's
connected
the
topics
writing
that
class.
they just didn't download all, so I
The
couldn't.
writing stuff?
Okay, okay.
Does she pass?
Alright, now, just so that we're clear, if Lisa had done all these steps right, and she did, an important thing to note is, first off, this is not the only way to have gotten to the ending road, okay? There are always multiple ways we could have done this, and we could have, as long as every step along the way is right, all these matrices are effectively equivalent. Now that we know the answer, that x is -1, y is 23, and z is 16, we could have actually, any place along the way, tried that and it would have worked. Like 1 times -1 minus 2 times 23 plus 3 times 16 is going to be 1. Any place along the way this would have, like now that we know the answer, I mean, it doesn't immediately glare out at you, but all of them are the same. That's a hard thing to sometimes see. It's even harder though to see in the form of like when we're writing them all out as equations. Okay? But as long as you've not broken any rules, these are all equivalent. They all have the same answer. Lisa, I almost hate to erase the board. You've done such a lovely job with it.
My brother did such a lovely job.
Your brother.
Yeah.
What does your brother do?
He's in the Air Force.
He's in the Air Force.
Yeah.
So you did this like remotely?
Well, I FaceTimed him while I was doing my homework.
FaceTime.
And then I was like, I don't know how to do this. I would already taken up half a page, and he's like, send it to me because he's a little nerd. So I sent
He's
it
a
to him.
little nerd.
And he did it like in 2 minutes.
Oh my
maybe.
gosh.
And then he was like, here. Like, why do you like
You know
it?
how much of a nerd? And I apologize. No, I shouldn't say it. All right. What is the? What's another problem that we were having questions
Number
about?
45.
Number 4. May I erase this?
Yeah.
It's permanently memorialized on YouTube, so it'll be a thing.
I'll send him the link.
Yes, please do, brother. Thank you. Where is brother?
He is in New Mexico. I know he's in Texas. Never mind.
Texas.
He's going to New Mexico in like December, I think.
Okay.
He's in Texas right now.
All right. Let's look at number 45 because most story problems are always kind of an interesting challenge. It's an investment problem. Catherine invests $10,000 received from her grandmother in 3 ways. With one part, she buys bonds at an interest rate of this. She uses the second part, which is twice the first, to buy mutual funds that offer that much of a return. She put the rest of the money into the money market account, paying this much interest. The first year, her investments bring a return of $470. How much did she invest in each way? Oh, Lordy. All right. We know. I haven't done this problem yet.
Like, I don't even know if I'm setting it up right.
Okay. Malia, tell me how you set it up.
I put x plus y plus z equals 10,000.
So you're saying-
that's the amount of money that.
So X is the amount of. Let's just be clear about
X
that.
is the amount of money she put in savings bonds.
Money in bonds.
Then y would be
Money
mutual funds.
in mutual funds. And Z
then
is
money market.
money in money market. I can live with that.
Which one is this?
Number 45. Did you get number 45 to work?
Nope, I did not do it.
You did not do it.
I
Where was your brother at all of this?
fell asleep.
Natalie, this is what happens in this class. Different crises happen in your class. I need a break between the 2 classes, frankly. All right. I haven't done this problem yet, so let's see if we can figure this out. She gets 2.5% on that. The second part is twice the first. And and she gets 6%. She puts the rest of the money into the account. So wait a minute. Right off the bat, we know something important, right? Y is twice x.
2x, yeah.
That sounds like an equation. Here's another equation. We know that x plus y plus z equals 10,000, right?
Yeah.
Okay? And we know something about how much interest she got. So we know that, like, for example, 0. What was the actual number? There was some tiny number. 2.5%. 0.025 times that money we have in bonds plus mutual funds plus 0.06 times y plus 0.045 times z equals $450.
And I got that, I'm just, 250?
Wait, 400,
470, okay.
470, sorry.
Sorry, that was my mistake, I would have cried.
Oh my gosh.
I've done this in every class, like instead of bare homework,
You
I've
need
been
more
doing
sleep.
this.
Alright, right off the bat, I am happy with this. What is it about this set of equations and so on that's making me happy that this is going to work? Because always it takes... Luis, what's up?
I'm done with work.
Okay, yeah, I'll just take it back. That's for... this is everything on that one assignment then, right? Okay. Okay. You have anything else you want me to do on that one? You're good with this? I mean, this can be like... Okay.
After we all see that we have
Alright,
I
go
set it up
do
correctly,
working
and I
on
still
those
get it wrong.
Alright. This is 3 equations in 3 variables. 3 equations in 3 variables is always a good thing. You should have the same number of equations as you have variables. That is a good sign. If you have 2 equations in 3 variables, you are not going to be able to solve it. If you have 3 equations with 2 variables, you might be able to solve it, but there's no guarantee you're going to be able to solve it. This is a good sign. I think we can agree this one looks familiar. It's something x plus something y plus something z equals something. Something x plus something y plus something z equals something. I don't know if I care for that one too much. How about if we rearranged it like that? Are those two the same thing?
Yes.
Yeah, let's get that out of here.
Would it be different if I put negative x plus y?
Yeah.
Wait a minute, which one?
Is it like that one? Like if I did negative?
If you had pulled the 2 x's over here,
Yeah.
so you made it minus 2x plus y plus z equals 0, plus 0 is 0. Yeah, that'd be fine. It's equivalent. The same answer is going to work. Yep.
Okay.
Alright, so we have a matrix here now. 2, negative 1, 0, 0, 1, 1, 1, 10,000. And, oh my word.
Did we just already
And I
multiply that
multiplied.
already?
You know what? There's no reason why we can't. Why don't we go ahead and multiply this by 1,000? Let's go ahead and make this, this.
That was me 10 minutes ago.
Does that seem good? Do I feel like I have broken any rules here?
No.
I feel like we have a system of equations here. Hey, let's do the Lisa brother thing and let's do a rearranging here.
Lisa brother.
Well, you know, I feel like an idiot right now because I stuck in an entire new row that eventually eliminated itself out.
Okay. Welcome to matrices. That's going to happen. Here, let's make this easier. Easier. Let's pull this. We know we want a 1 down here, and we want to get. Here's an idea. Let's pull this 1 with these right here. Let's just pull these guys out and put them down here instead. All right, I'm rearranging. All right. So now I got a 0. I'm happy here, and I'm happy here. Right. All right. Now we're happy in those 2 places there. Are we in agreement that this math problem is a pain in the butt?
Yes.
Yes, 110%.
You know what I think would be helpful?
Not doing it.
You are pulling an interesting attitude.
I've had this equation set up. I set it up correctly. I've done it 4 times and they all are different answers.
That's a big thing.
I'm just going to set up that matrix that we have right there on the spreadsheet. Hold on. -1,
That's what this is.
0, 0,
Why am I honored? You don't end up with this much fun.
25, 60, 45, 470, 000, 1, 1, 1, 10,000.
It's My mom was thinking.
Did I do this right?
Kids have the same without you.
Alright, let me look here. 0, dot, dot, dot. Yep. 25, 60, 45, 47,000, 407,000. Oh, nope, nope, nope. Alright. These are the same problem.
No, not spreadsheet again.
I'm not gonna do a bunch of arithmetic like I'm a circus animal here to perform for you.
Wait a minute, you're not
You
doing
sound
that
so
out.
insulted.
Oh, sure. Well, Leo, what's up?
Are you just like using the function on there? 'Cause why?
No, I'm not gonna just use the function yet.
Okay.
Actually, I'm not sure if there's a Gauss-Jordan function in Google Docs. I'm not sure. But I'm just gonna do some arithmetic here. I just hate doing a bunch of arithmetic the hard way. Alright, so I've already, look at this column here. I wanted 0, 0, 1. I've got 0, 45, 1. So if I took, I'm going to leave row 1 alone. I'm not doing a damn thing to it. I'm leaving row 3 alone. I'm not going to do a damn thing to it. But row 2, I want row 2 to be row 1 minus 45 times row 3. I'm sorry, row 2 minus 45 times row 3. So that I've made this one 0. Does this need to be bigger? Would people be happier?
No, I think it looks fine.
Are you okay? Maybe I should make it bigger anyway because of the YouTubing.
Wait, what did
Wait,
you do
can
again?
you
Sorry.
I zoomed in.
explain what you just did?
No, what
With the zooming or the making the things?
Make it zoom in.
Alright, I did not change row 1. I just copied it from the previous matrix. I did not change row 3. I just copied it from this previous record. But to get row 2, to have this one be a 0, I made row 2, row 3, I'm sorry, 45 times row 3 minus row 2. Right, is that what I did? Wait.
45 times?
Well, because I want 45 times this minus this.
Which is 0.
Actually, I did it the other way around, didn't I? I did this one minus 45 times this one,
Which is 0.
which is 0. And that changed all these two, right?
Row
Okay?
2 minus
I got rid of that one.
45 times row 3.
Yep. Alright.
How's your
I gotta get rid of this one. Right? Here's a -1 right here. Now, it would be a temptation to say, oh, I get it, let's take row 1 and add row 3. Right? Because then they'd be canceled out. But what's going to happen over here? My hard-earned 0 over here will become this plus this, it'll become a 1. I will have accomplished a big fat nothing. I want to work with these two rows because if I add these guys together, these guys will just be adding zeros. So, to make this thing go away, using this one, how about 15 times row 1 plus row 2? So, real quick here, let me just copy this guy down. Here's the whole matrix. Oops, sorry, what's going on here? There. I'm going to copy this whole guy down here. I've changed nothing. But now I'm going to change, so row 2 and row 3 are the same, but let's change row, uh-oh, sorry, hold on,
You need
undo,
Sandy.
hold on, copy. I got a face special here. There we go, okay. So, alright, so I want row 1 to become 15 times row 1 plus row 2 equals 15 times row 1 plus row 2. And if I copy that across, look what happened. I got rid of another one. 15 times this plus this goes here. Everything else stayed the same. 15 times this plus this goes here. 15 times this plus this. And look at this. And look at this. 1, 2, 3. We got those 3 done. Alright, now, this is where I always get stuck. Which one do I want to do next?
Row 2. No, wait, no.
These
row
guys?
2. Oh.
I want to get rid of this one. So, now, if I played some games where it involved, let's see, I want to replace this one. How about if I said 15 times this one minus this one? Because 15 times this one minus this one, it won't be a 1 anymore, but at least I haven't gotten rid of any of my zeros. Right?
I was going to say get rid of the 20 because you have that
Yeah.
10.
So what do you want to do here? You want to do 2 times this plus this
Yeah. And then
goes here?
Yeah.
2 times this? Okay, let's try that. You might be right. I mean, there's not a single way to do it. So let's try this. Lisa says, replace this row, the second row, with 2 times the first row plus the second row. And that did make a 0 there. And it didn't break anything else. So far, so good. Okay? I'm not telling you to solve this using a spreadsheet. I'm saying I don't want to be doing a bunch of arithmetic in front of the crowd. Alright? A hunting we shall go. How about this, get rid of this 1 right here? Does that make sense?
Yes.
Alright, let's do that one next. I'm going to copy and paste this guy down here. I have to do space special. So I don't get the equations, I just get the numbers. Alright, we're aiming for this guy. We want to get rid of row 1. We want this guy right here, rather. How are we going to get rid of it? How about this one minus 10 times row 3? Row 1 minus 10 times row 3. That did get rid of that. Okay. Whoa. We can always divide by -10 later. I mean you see what? Did you hear that anxiety that built Lisa? I bet it was because of this one, right?
Yeah.
Yeah. This used to be a pretty little 1 right here, which is what we're looking for. Now it's not anymore, but who cares? We can always divide later. Okay. Hey, we are pretty damn close to having this one to work. I only see this guy as being a problem now.
Yeah.
All right. Let me copy these guys down. How's it going, Natalie?
A problem came up.
Another problem?
On your iPad.
Natalie, this problem
The
are
problem
very
is
scary.
she's not even in the class.
All right. I think if we took twice row 2 plus 3 times row 3, how about equals twice row 2 plus 3 times row 3? Hey, because twice row 2 was 30, plus 3 times -10 is -30, that's a 0. And look, now everything is well, we got to divide each row by the necessary number to get them into that 1, 1, 1 type format. So, yes,
How did you get to the one before that?
to this one right here.
Yes.
This one's operations were, I got rid of this cell that is highlighted right here by saying row 1 minus 10 times row 3.
Okay.
So this one minus 10 times this. I should be writing it over here so that I do it, but whatever. This one minus 10 times this. This one minus 10 times this. Well, it kind of made a mess of it, but we can get there. Alright, so now I just need to divide each row by what it takes to make those things a 1. So like for example, we want this one divided by 10. We want this one divided by 15. And we want this one divided by -30. And just copy that across. And look! We have answers! I think we have totally scared Natalie out of taking this class.
I honestly took it because you were teaching it.
Lisa, that is so sweet.
Yeah, that was, I didn't want to take calculus either.
What?
I didn't want to take another
I
math,
also
but
didn't want to take calculus, I don't even know if that was an option.
Calculus is next semester. Well, you can take calculus, I think, this semester with Ivy Tech teachers.
yeah.
Or at your home school.
Wait, next semester, we take.
But next semester, usually, as I understand, usually people take finite this semester, take calculus with me next semester is the plan.
Yes.
Yeah.
Oh, that's what we're doing?
Yeah.
That's the plan. You don't have to
Luke,
take it next semester.
Luke.
Might as well.
It's going to be good.
It's a college
Yeah.
credit.
It's college credits. Like, so look at this. Does this answer make sense, by the way? 2 of the things we knew. It had to add up to 10,000. She spent 10,000. It had to add up so that the second thing, whatever it was, mutual funds or some such thing, was twice what she got in bonds. That adds up, right? I don't feel like adding up all the percentages to see, check her answer. That like 2% of this and 6% of this and 4.5% of this adds up to $470. I'm going to have a little faith. Boy, those are nice round numbers. How do you think the guy really made the problem? He probably really did it the other way around, right?
Yeah.
He probably really sat down and said, okay, I'm going to solve this, this, and this. These are the numbers I'm coming for, and then make the problem work out, right?
I feel bad for people who have to make math tests.
They must be the saddest human beings.
I mean, if they love math, then the saddest human being.
Look at the back. Look at every section of every section in the pre-calc book. Like after section 4.2 or whatever, there's like 180 some questions. The calc book is particularly sad. I mean, there's literally like 150, 200 questions after every section. Who wrote all those questions and checked them and put the answers in the back of the book? You know how hard it is to type one equation in like Microsoft Word? They've typed thousands of them.
And also, like,
They're sad.
who's checking them?
Yes, that's right. There's got to be like reviewers and grad students whose job it is to check them because there's got to be mistakes.
They gotta be making big money.
And then they're making the big grad school money. Probably minimum wage plus $1 an hour. All right.
Look at them go.
Actually, they probably make nothing. That's the problem. All right. I feel empowered by having done that one.
Well, I didn't even get more empowered by setting up number 47.
Setting up number 47.
I just did not know I could deal with
There
the
you go,
front end
so.
side.
I'm sorry about your head. And I'm sorry about the deadness.
It's okay.
You're going to feel better when we do the next thing. All right. Which problem was it?
Number 47. I just don't want to read the part.
Number 47. That's not even the right course. Hold on. Number 47. Malia, tell me about that problem.
Okay. Fred's Furniture Factory has 1,950 machine hours available each week in the cutting department.
Oh, yeah, okay.
1,490 hours in the assembly department. 2,160 in the furnishing
Turning
department.
this up,
Yep.
so I don't know what that means.
Manufacturing a chair requires 0.0
Kitchen.
No, 0.2 hours of cutting, 0.3 hours of assembly, and 0.1 hours of finishing. A cabinet requires 0.5 hours of cutting, 0.4 hours of assembly, 0.6 hours of finishing. A buffet requires 0.3 hours of cutting, 0.1 hours of assembly, and 0.4 hours of finishing. How many chairs, cabinets, and buffets could be produced in order to use all the available production capacity?
MJ is dead inside. But Haley is... I don't know. Haley, tell me about, did you get this problem to work?
Oh, you genius.
I always have like huge confidence in Haley.
I feel like it's a lot of unnecessary work, but I got the right answer. I got some right there before I gave it to bed.
Okay, she got a long ways. Let's take a look at this. Hey, what are we solving for here?
None of it.
I have no clue.
X, Y, and Z.
I would agree. X, Y, and Z sounds like a good thing. What is X and what is Y and what is Z?
Chairs, cabinets, buffets.
Chairs, cabinets, and buffets. What about them? Like, how much to charge for them?
How many?
Yeah, the number of each of those things. Number of chairs, number of cabinets, number of buffets. All right. So, we know it's going to take a certain number of hours of cutting, a certain number of hours of assembly, and a certain number of hours of finishing for each of these things. Let's see here. We have cutting. Let's do cutting first. Cutting. We know that we have a certain number of machine hours, 1,950 of them. And we are however many, okay, so chairs. We're going to need 0.2x. We're going to need 0.2 hours times the number of chairs we make, plus, where's the cabinets? Let's see here.
It's 0.3x plus 0.4y.
No, wait a minute.
Oh, we're still doing cutting?
I'm doing cutting. So it's 0.5 hours of cutting per cabinet. And how many hours of cutting for a buffet?
I gotta set it up now, okay.
You got it?
Yeah, I can't promise you the math will be right, but...
Okay, so however many chairs we make, it takes 0.2 hours per chair. However many cabinets we make, it's a half hour per cabinet. If however many buffets we make, it better add up to $1,950 hours. All right, and we can do the same thing with assembly. This is assembly. People keep peeking in through our window. I wonder what's going on out there.
They're wondering what's going on here.
Yeah, this is like the most interesting.
This is the most interesting class.
Yes.
All right, we'll wait till you see. All right, share. 0.3 of assembly plus a cabinet needs 0.4 of assembly, and a buffet needs 0.1 of assembly. That means they can assemble it in 1/10 of an hour. I can't even imagine they can build something in 6 minutes, but whatever. And that Fred, he makes some damn good furniture. And finishing. All right, are we comfortable that we got this stuff set up?
You could multiply the whole thing by 10.
Yep, and get rid of all those decimals.
Yeah.
I did not realize that.
That would make things less anxiety. You're right. One thing to do would be to, in general, if this is especially if the left-hand side starts getting full of either fractions or decimals, in a textbook type problem like this, a good idea is to get rid of that by multiplying by whatever you need to get rid of that. And the reason why that's a happy thing, hi Natalie. The reason why that's a happy thing is because, you know, it gets a little harder to have a plan as to how to get rid of stuff. I don't want to spend all day going through the arithmetic of this. If we had an extra few minutes, I would make Haley come to the board, which she would hate. I get the impression she likes to be quiet and just sort of hang out in her corner. Is that right?
Big bull.
Is that a Haley thing?
Big bull.
What?
Sometimes.
Sometimes you like to go to the board?
Sometimes. Every once in a while.
How about not today, though? Okay, because what we're going to do, what was the assignment on this anyway?
It was.
Did you have to go farther than 49?
47 was the last one.
Well, wait a minute, 47. This is 47, right?
Yes.
So now you have it set up. So in theory, you could finish this one.
Oh, in theory, yes. If
But do I want to?
something-
Lisa, you always do this where you're like, I feel like I don't know how to finish this, or I don't know how to do this.
I feel like I do, but it's just like I would mess it up.
Here's the deal. You guys stay until Monday to finish this up. Because I feel like, in general, I don't want to get in the habit of making extensions on assignments. But especially since I frankly think that the assignment you're doing for Monday in this class is kind of smallish, I feel like actually if you needed to spend a little time finishing number 47 or fixing number 45, that's not a bad use of your time. Okay? Because here's the deal. Let's talk about new material today.
Oh,
It's not much. And it's something that all the people who have already taken pre-calculus have already done to death, which leaves only MJ. And she's going to be like, you gotta be kidding, that's no big deal at all. It's more about matrices.
That's
What?
what you said about this one, but you know, I'm still
I
dead.
build confidence.
And
And then we
just-
pull it out from you like a rug. No, just kidding.
Yeah, that's how.
Yeah, that's how it feels sometimes. Okay, matrices. You've been doing something now with one homework set about matrices. You got numbers in a matrix. 4, 3, 7, 0. Hey, that's a matrix. It's like a little table. In a fancy modern algebra kind of way, these things are actually ways of saying numbers, but that's a complicated idea we're not going to go. But we can give these guys names. I mean, this could be the matrix A. And we could have a matrix that we'll call B.
Oh my.
How about 1, 1, 5, 0? Alright? We got matrices, and they can have a name. A, B. And we can do things to matrices. Here, I'm going to put another one over here. C. How about this guy?
why is you said this is friends?
Yeah.
What? Are you
C
talking?
is so far from A and B.
Yeah, he's allowed.
Who?
C.
Is this
Luke.
like multiplying? Because I really
Luke.
think at multiplying.
It takes a special soul
That's the guy in the kitchen.
to have recognized how lonely. You need to talk to somebody at counseling. Are you relating to the C matrix that you are also distant and isolated from the A's and the B's?
I mean, I sat
Are
next to
you
both.
associating
Oh, me and
with
Andrew are the A and the B, and he's the C.
Uh-huh.
At one point, I sat next
Possibly.
to both of them at the beginning of this class, and now I'm back here.
No one pushed you back.
I
One
give
day
you,
you got here so late
This
that
is
you
my
just
will
went
to
back.
Natalie, this is what happens in
And
this
that's
class.
me.
It's a different chaos in your class. I'm sorry.
That's all.
Anyway, all right.
I don't see it.
What can you do with these matrices?
It's not.
What kind of things can you do? Can we do things like A plus B?
Yes.
Absolutely. And it's ludicrously simple, MJ. It's embarrassing
No,
that
I know how to do this
You know-
surprisingly.
you know, like you add them element by element, right? 1, 5. 1, 3, 1, 7, 5, 0, 0. Adding is not a problem at all. Right? Wait a minute. Let's add, here, let's make C a little special. Here.
Oh.
Can we add A plus B, A plus C?
No,
Nope, can't happen. Why?
because there's too many.
I'm bigger.
Too many columns. Yeah, the word your book is using is size. I don't think size is the right word. I think actually the right word is rank. But whatever. They don't have, what would you do? I mean, how would you, what are you going to do with these? It doesn't exist. You can't add them if they aren't the same shape. How about subtraction? Can you take A minus B?
Yes.
Sure, as long as these two matrices are the same size, you can just element by element go through, and this one minus this one, this one minus this one, this one minus this one, this one minus this one. Then you do it over here, A minus C. Big no, they're not the same shape. They're not the same size, to use a term that your book actually highlighted in bold. No big deal. Can we do something like multiply these matrices by a number? Can I take 3A?
Yes.
Yeah.
Yes, you sure can. And what is it?
12.
9, 21, 0. All you do is you just multiply each part of it by the scalar that's on the outside, the number that's on the outside. It scales the matrix. It scales the matrix. Sounds like something that happens in a Keanu Reeves movie or something.
Oh, like the Matrix?
Yeah.
Whoa.
Whoa, mind blown. Take the red pill.
The Matrix.
See how deep the hole goes. Wait a minute. What else can we do with these? How about multiplying the matrices themselves?
Yeah, you can do that.
Yeah.
As long as they're the same size.
Ah, no. No. But some you can and some you can't.
Okay.
That's good.
That's fine.
The game of how to do it's not so hard. You guys remember, right?
No.
It's you go for each. Okay.
I actually really was bad at this, and every time I have it on my test, I have to flip over to my notes and look at an
Oh, yeah,
example
me
as I
too.
did.
Now
I have
it's
to
gonna
think
be in
which
your
one
brain.
should I-
Struggled
No.
with this part.
Okay.
Not gonna lie.
To get, I like somebody's use of the words rows and columns. To get row 1, column 1, we're going to use the row of this, we're going to use, to get row 1, column 1 of our product, we're going to use row 1 of the first one and column 1 of the second one. So, let me clear out everything that's cluttery here.
That's helpful.
Row 1, column 1. This times this plus this times this. So it's 4 times 1 plus 5 times 3 is 19. To get row 1, column 2, you're going to use row 1 of the first matrix, column 2 of the second one. Row 1, now it's this guy. 4 times 1 plus 0 times 3 is 4. Yes, Andrew.
Can you make it so there's like letters in each of them?
Sure.
Can you write the letters on the side?
Oh yeah.
'Cause
If that's helpful, we can do that. A, B, C, D, E, F, G, Q.
Q.
Just messing with you.
That's not.
Gross.
Oh, fine. Jeez.
Make it an L.
I don't think you know how much my sister's struggling.
What is sister struggling?
A
Sister struggling.
sister.
What does that even mean? I don't understand.
Just look up James Charles tonight.
I don't even know what that is.
Sister's 13.
So, to do row 1, column 2, you take row 1 of the first, row 1, column 1. Let's do row 1, column 1 first. You're going to get this one here, row 1, column 1, you take row 1 of the first matrix and column 1 of the second. And it'll be A times E plus B times G.
That'll just be like one number.
And it's just a number. Yep. And then to get row 1, column 2, you'll use the first row of the first matrix and column 2 of the second. A times F plus B times H. A times F plus B times H. And you guys did this to death at Brinko. Once those brain cells like start getting moving again, you'll be like, yeah, no problem.
No.
And not, okay, so second row. Row 2, column 1 will be row 2, column 1. CE plus DG. CE plus DG. You just let me have that Q in there. And then the final one, row 2, column 2. Row 2 of this matrix, column of this. C, F, D, H. C, F plus D, H. But I'm doing this with a 2 by 2 matrix, but lots and lots of different sizes will work. How will we know if it works? It has to have, here's the pattern. Let's describe the size of A. I think we can all agree it's 2 by 2. The question is, what do we mean by 2? It's 2 rows by 2 columns. And the second one here, this one is 2 by 2. It is 2 rows by 2 columns. If, I think it's, oh crap, which way is it? Let's find out. Can we do A and C? Here, I'll put some numbers over here. Where were we? H? I, J, K, L, M, N. Can we do A times C? All right. First row, first column. First row, first column. A times I plus B times L. A times I plus B times L. And it worked. How come it worked? This matrix is 2 by 3. 2 rows by 3 columns.
So
As long as the number of columns over here matches the number of rows over here, it's going to be fine. Number of columns in the, number of rows in the first one has to be the number of columns in the second one.
So that doesn't work.
no,
Wait a minute, hold on.
number of columns in the first.
Columns in the first one.
Yeah, that's right.
Is that right?
Yeah, that's right. I think that's right.
Yes, columns in the first one has to match the number of rows in the second one. That makes sense. Number of rows in the columns in the first one has to match the second. I always remember that when you write it down, it's those. I always get confused because I got all kinds of dyslexia going on. So plenty of them, it's not possible. Let's see what happens. C times A. Okay, that would mean that we only have the number of columns in that first one, C, which is 3, is equal to the number of rows in the second one, which is 2. It should not work. Let's find out if it doesn't work. So it should be the first row, the row of this, times the column of this. I times A plus J times C plus K times there's nothing there. It doesn't work anymore. So some sizes work and some don't. You can always do the product if you have the number of columns in the first one matches the number of rows in the second, then it will be fine. Somebody said, well, what if the 2 matrices are the same size? Well, that wouldn't work. For example, what if we had C times C? That would be 2 matrices that are the same size. But notice that the number of columns in the first one doesn't match the number of rows in the second one. So it wouldn't work. You wouldn't be able to do it.
Would that be about like if you're doing A times C, would it be
A times C? A times C. Let's go farther here. A times C. Okay, first row, second column. A times J plus B times M. Are you good with that, MJ? Okay, third column. A times K plus B times N. Okay, next one. First column, second row. C times I plus D times L.
Yes.
Second column. C times J plus D times M.
Yes.
Okay, third column. C times K plus D times N.
Yes.
Okay, great. See, this is not hard. In fact, for some reason, your book actually, the teaching plan that they give us from the school says to take 2 whole days on this. I thought more like a half day. I was pretty sure that, I'm guessing that everybody in the school district, when they hit this part, they really use it exactly for what we did. We had time to talk more about the things we just covered. I can't imagine anybody really spends 2 whole days actually on this material.
We tell you to spend 2 whole days.
Yeah, there's like a
One day
curriculum
just
map or
on the
whatever.
audition.
What?
One day just on audition.
I would have to bring nachos or something if we had
Yes!
spent, look in the book, there's 1 whole day just on adding matrices.
If we all,
How hard was that adding the matrices thing?
at the end of the year,
Really
if we all
hard.
pass
Next
this
time.
class,
Next time.
at
should
the
have
end
a
of
nacho
the,
party.
yes, if we all pass this class in the year, can we get a nacho party?
100%.
And what if we all pitch in for the nacho?
I think
Someone
if
fails.
Luke gets here on time every day for the rest of the semester.
How about we take it one day at a time? How about we all chip in, we get donuts on Monday?
I don't know, I just think that we should.
How about we all do nachos next time?
I don't know what the rules are on things like that. Hold on just a second here. So, you have an assignment, but it is not going to break you. Even dead inside MJ will survive this one. Page 74, you're going to do, you know I'm just teasing you, MJ, right? 21 to 32 all. 21 to 32 all. And you're going to do on, that's actually on that one. And then in page 83, you're going to do 1 to 6, and that's all, and 15 to 22.
Is that it?
That's it. And I mean, these are just like matrix additions, and these are, it's all like add these 2 matrices if it's possible. And some of them are, it's not possible. And these are all multiply these 2 matrices if it's possible, and some of them are, it's not possible. So hey, you want to take a quick not pop quiz, exit ticket? I don't think I have it posted yet, hold
My
on.
will to live has slightly returned.
Alright,
I
MJ.
haven't.
Let me fix the,